2. Introduction to the basic functions of the software. Open the software. The first time you open the software, there will be a guidance step. Click Start. Agree, Next. Add printer. Here is the example of Ender 3S1. Find and select Creality Ender 3S1 in the list of printers. Click Next. Here you can see the code of some machine parameters. If you are a beginner, it is recommended not to make any changes. Click Next to enter the slicing screen. Switching language. Click on Preferences, Configure Creality. Click on the first column. The first item is the language option. Select the language as needed. Window operation. When you enter the main interface, there is a grid area. This area is the printing platform area. When slicing, the model should not exceed this area. First, let's get familiar with the operation of the mouse. The right mouse button is the menu button and the rotate view button. Click the right button to bring up the menu options. Long press the right button to drag the screen to rotate the image. Mouse wheel is to zoom and pan the image. Scroll forward to enlarge the image. Scroll back to narrow the image. Long press the scroll wheel to drag the screen to pan the image. Software function key instruction. The first step in slicing is to import the model file. There are two ways to import models. Click on the folder icon in the upper left corner. Or click on File, Open Files. Find the model file to be printed. Click Open. The model is imported into the slicing software. Second, outside the software. Find the model file and drag it directly into the slicing software. After importing the model, a list of function keys will appear on the left. You need to click to select the model to activate the function option. Multi-selection requires holding down the Shift key at the same time. Select the model you want to change. Activate the function options on the left side. In order from top to bottom are Move, Scale, Rotate, Mirror, Support Blocker, Customize Supports. The letters in brackets are shortcuts to their functions. Press the corresponding letter directly after selecting the model to activate the left function key. The following will explain the function keys on the left and how to use them. Move, T. The coordinates of the model are shown on the right. You can change the position of the model on the print platform by dragging the model or entering the coordinates. When the model is not on the printing platform, the model will become gray and yellow in color. The position of the model needs to be adjusted. Check Lock Model. The model will be locked. The model position will not change anymore. Uncheck the Lock Model to continue moving the model. When multiple models in the platform are confused, you can use the Ctrl+R keys to quickly and automatically put the models into place. Scale, S. The size of the model is shown on the right side as a percentage of its original size. Scaling can be done by filling in the size or percentage. You can also drag the three axes on the model for scaling. When the model size is larger than the maximum print size of the printer, the model will also change to gray and yellow color. Click Reset. The model returns to its original size. Rotate, R. By default, the model can be rotated by dragging the three axes on the model. The rotation methods are shown on the right. As follows: Reset, Lay Flat, select face to be aligned to the build plate. Clicking on Lay Flat will automatically rotate the model. Click on Select Face to be aligned to the build plate. You can make the face of the model horizontal by clicking on it. This function can only be used for a single model. This function is not available when multiple models are selected. Click on Reset to restore the model angle to its original state. Mirror, M. Allows the model to be converted to mirror symmetry. Just click on the direction where symmetry is needed. Support blocker, E. When the computer automatically adds support, some places cannot add support, and support can be intercepted through the support blocker. Click on the area to be blocked. A gray transparent square area will be displayed. No support will be added to the faces in this area. You can cancel the support blocker by selecting the gray transparent box and pressing delete or double-clicking on it. Custom supports, C. The parameters of the support are set on the right side. Add support manually. With the automatic addition of supports cancelled, manually add support to the place where support is needed. In the bottom left corner, there is a list of objects of the model. You can edit the objects you want to edit here. You can also click on the model directly to select it. A green-blue stroke will appear on the outside of the selected model. The size below is the maximum outer size of all models combined. The bottom one is the View Switch shortcut key. You can quickly switch to a specific perspective to observe the placement of the model. One thing to note about the model placement is, when the coordinate system on the corner of the printing platform is rotated to the bottom left corner, that is, the front view. This view is the view from the front of the printer in reality. Next, let's introduce the function of the right mouse button. When you select a model and press the right button, a list of options will appear. Here we will mainly focus on the last three options. The other options are literally the same. Group models and merge model require multiple models to be selected. Group models. When editing multiple models, individual models can be grouped together. Relative positions can be fixed within the same group. No touching between models. When editing position, scaling, rotating, mirroring, etc., editing will be done in that group. Ungroup models. After using the first two functions, if there is no need to continue grouping models or merging models, you can use this function to split the model into individual models. Merge models. Based on the group model, merge models with surface-to-surface contact. For example, the imported model is a parted model. This function allows you to merge models into one overall model. It is important to note that 1. Merging and scaling models should be done in the order of merging and scaling first. If the model is scaled first and then merged, the original size will be restored after merging. Two, the merged model can't be flattened by select face to align to the build plate. In this case, you can first export the merged model to a new STL model file. Then re-import the model. The steps are as follows. Select the merged model. Click File. Export selection. Rename the model. Select STL file as the save type. Click Save. Delete the merged model. Import the model you just exported. Printer management. You can add, manage, and switch printers quickly. Material parameters setting. Set the type of material to be used and the nozzle aperture size. Be sure to clarify the material type and the nozzle aperture before slicing. These two settings, if set incorrectly, can lead to print failure and even damage the printer. So be sure to set them according to the actual situation. Slicing parameter setting bar. Modify the slicing parameters to improve the print quality. Different parameter settings will have different printing results. The parameters initially recommended by the software are suitable for users who are new to printing. Set the parameters by yourself after you have a good understanding of the printer. Click on Custom. There are a series of options for setting the printing parameters. The first line is the print settings. The printer's printing parameters can be quickly modified by switching between different slicing profiles. After the profile name is marked with the layer height, the smaller the layer height, the smoother the printed model will be. The higher the printing accuracy, the longer the printing time. Select the print profile according to your needs. The following configuration options are commonly used configuration options. Some configurations are not displayed by default. The user has to call it by himself. Click on the menu bar to the right of the search box. You can see that there are several levels of options. The default configuration options are different for different levels. The higher the level, the more parameters are available. You can also customize the list of options. Click on Manage Settings Visibility and find the setting you want to bring up. Just check the box. After selecting an option, drag the mouse over a sub-option and a description of the option will appear. Some sub-options need to be moved by yourself. Select Standard Level here, for example. Modify Profile. Quality. The modified parameter is the layer height for printing. The principle of the printer is to cut the whole model in several small layers, by accumulating layer by layer to form a whole model, similar to building a house. And the printed model surface will appear layer by layer pattern. This is the layer pattern. The model printed by the FDM 3D printer will not have the same smooth surface as the injection molded model. By touching the model, you can clearly feel the layer pattern. This is inevitable in 3D printing. The higher the layer height, the more obvious the layer pattern is. The smaller the layer height, the more delicate the layer pattern and the flatter the surface. Generally, the recommended layer height setting is within the range of 0.1 to 0.2 millimeters. If the printed model does not have special attention to the details of the surface, you can set a layer height of 0.2 millimeters. If you need to be more delicate, you can set it to 0.16 millimeters. This can save time. If you are printing a handicraft model, you need a smaller layer height because of the small size. It is recommended to set 0.1 millimeters or 0.12 millimeters. Shell refers to the thickness of the shell of the printed model. The higher the wall thickness value, the harder the model will be. Small models are recommended to be set in the range of 1.2 to 2 millimeters. The value is generally set in terms of the size of the nozzle aperture. When printing large models, it is necessary to increase appropriately according to the situation. Here set to 1.6 millimeters. The top/bottom layer thickness is recommended to be set the same as the wall thickness. Here also set to 1.6 millimeters. Infill inside the model. To increase the stiffness of the model. It also serves as a support when printing the top more horizontal surface. The larger the infill, the more material is used to print and the heavier the model. When the fill is set to 0, the inside of the model is hollow. When set to 100%, the model will be printed with a solid interior. The recommended setting is between 15% and 25%. The setting here is 20%. The fill pattern can be selected according to your preference after checking the instructions. Generally set to cube. Material. Set material-related parameters. Mainly set the printing temperature and flow rate. Setting the temperature of nozzle and printing platform need to be set according to the performance of the material and printing speed. The four main materials commonly used for FDM printing are PLA, ABS, TPU, and PETG. The same type of material will be different depending on the manufacturer and the optimal temperature. Generally, the recommended temperature settings are indicated on the packaging of the material, but it is better to test the material before printing. For example, test the printing effect of the material at different temperatures. In addition, the faster the printing speed, the higher the temperature of the printhead should be to avoid clogging. Click on the pinion on the project. Open the option Settings Visibility. Check the flow option. The flow rate is the amount of material flowing out of the nozzle per unit time. Sometimes there is a shortage of extrusion when printing. For example, the material inside the shell is not adhered. In this case, the flow rate should be increased appropriately. For the first time, just use the default settings. After you have a certain level of experience in printing, you can make more detailed adjustments. Speed. The speed at which the model is printed. The faster the speed, the shorter the printing time. But the disadvantage is that the quality of the print will be declined and noise will be made. The slower the printing speed and the longer the printing time, the better the printing quality will be. Especially for models with a lot of details, the printing speed needs to be slowed down, generally set between 30 to 60. Travel. The main parameters to be modified are the retraction. That is, when the nozzle moves above the non-printing area, the material is extracted back, which can avoid the filament phenomenon. Click on the pinion on the project. Open the settings visibility of this option. Retraction distance and retraction speed. Mainly modify the retraction distance and retraction speed. Normally no changes are needed. Modification is required only when straining occurs during printing. It is recommended to turn on the Z-axis lift during retraction. Cooling. Mainly modify the fan speed, usually no need to modify. Support. When printing some inclined surfaces and overhanging surfaces, the material will be depressed downward because there is nothing under the surface to support it. It will cause the model to be deformed, resulting in printing failure. When adjusting the angle of the model does not solve the problem, then you need to add support. When the support is properly set, the printing will be completed with less time and effort. If the support is not set properly, even if the printing is completed, it may be stuck in the step of removing the support. In the function keys on the left, there are Custom Support and Support Blocker. Custom Support allows you to add support to any side according to your needs. The Support Blocker is to block the support from being added to that side. Double-click to cancel the support. Open Generate Support and the computer will automatically generate the support. In Setting Visibility, you need to check and open Support Structure, Support Placement, Support Pattern, Support Wall Line Count, Connect Support Lines, Support Density and Support Z Distance. The support structure is usually selected as normal support, while tree support is used in more complex models. And tree support is more material and time-consuming. You can click on Slice Preview to observe the difference between the different ways of support. It can be observed that all the faces that meet the requirements have added supports, and the direction of adding normal supports is vertical, and the shape is more regular. Switch to tree support. The shape of the tree support is an irregular tree pole shape. Select everywhere for support placement. Then all sides on the model that are eligible for support will be supported. If it is selected touching build plate, only the sides that are mapped to the printing platform will be added to the support, while the overlapping sides will not be added to the support. As shown in the preview, the sides in the overlap area are in a suspended state and no support is added. And in this mode, the custom support added to the overlapping area will also be disabled. When setting the support, some sides can be identified by judging whether the support should be added or not. In this case, the support can be edited by Custom Support and Support Blocker. For example, the upper sides of the model do not have much tilt, but in order to prevent the upper part of the model from having too much mass and tipping over during the printing process, you can add some supports to that sides. But not the more support you add, the better. Some small supports may not be able to attach due to the small touch area at the bottom of the support. Make the material that should be printed on the support printed on the surface of the model, resulting in some burr phenomenon. For example, some sides are eligible for adding support, but it is observed that the side is not suspended, there is a connection, and the undulation is small. Then use the support blocker to intercept the support of the side. So in general, to add support you need everywhere with Custom Support and Support Blocker to use. Support overhang angle means that when the angle between the sides of the model and the vertical direction is higher than this value, the computer will judge that side as the side that needs to add support. The red area on the model is the surface that the computer judges to be in need of support. Generally, the printer can print a 60-degree surface, so the surface less than 60 degrees does not need to add support, so set to 60 degrees. The support pattern can be selected according to preference. We recommend choosing line or zigzag. Set the support wall can be hardened support, but hardening the support will increase the difficulty of removing the support. Generally, it is recommended to set connect support zigzags to 0. If you really want to stiffen, just set it to 1. Support density is recommended to set 10% to 15%. If printing small models, the support density can be increased appropriately. The support Z distance is usually set to twice the layer height. It is not necessary to turn on Generate Support to add support. You can also turn off Generate Support and use Custom Support to add it yourself. However, you need to look at the model carefully so that you do not miss the sides that need support. The build plate adhesion, turn on skirt line count and brim line count in setting visibility. The printing platform attachment type has 3 options. Skirt is a line printed around the model but not connected to the model. This allows you to observe the material output while printing the skirt and make adjustments to the printer in time for the main printing. The recommended setting is 3. Brim adds a single layer flat area around the base of your model to prevent warping. Recommended setting is 10 to 20. The option should be turned on if the touch surface of the bottom layer of the model is small. Raft adds a thick grid with a roof below the models. Before printing the model, a thick grid is printed under the print area of the model. This grid compensates for the effects of an uneven printing platform, allowing the model to be printed on as level a surface as possible. But it takes more material and printing time. You can choose it according to your situation, or you can leave the build plate adhesion enabled. Finally, click on Slice. Before saving the file, you can preview it to see if the support is in place and modify it if there are any problems. When the parameters are modified, a new configuration file is automatically generated. Click on Profile. You can see that the Create Profile from Current Settings/Overrides feature is active. Click on this option to archive the new configuration. It is easy to retrieve the configuration when it is modified later, just rename it. Configuration files can also be imported and exported. In Preferences, under the Profiles option, select the profile you created and click Export to create a .qwrapprofile file to save it. This way, when slicing on other computers, you can quickly configure it by importing the slicing file. To import a profile, click Import, find the profile in .qwrapprofile format and click Open. Click Activate to switch the current configuration. Note that when the software is upgraded and newly installed, the slicing configuration file in the software will be emptied and needs to be re-imported. The model and software version used in the exported and imported slicing configuration should be the same, otherwise there will be problems in the printing process. When the printing parameters are set, click Slice, the computer will proceed to slice the model. After the slicing is completed, you can view the approximate printing time and the amount of materials required as calculated by the software. However, the actual printing time and material required are larger than the result calculated by the software. Therefore, it is recommended to use the software's calculated value plus 10% more as a reference when scheduling printing. Click Preview to see the printer's printing path. Drag the progress bar on the right and bottom to adjust the preview printing status. Make sure the slicing steps are OK, then save and export the sliced file to the mobile media.